Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on January 22, 2026, about 5 days ago. It introduces a plug-and-play module called DeepVerifier that allows research agents to verify and refine their own answers during inference, boosting accuracy on challenging benchmarks by 8 to 11%. The paper is titled, Inference Time Scaling of Verification, Self-Evolving Deep Research Agents via Test Time Rubric Guided Verification. And as we'll see later, the results for improving agent reliability without extra training are really impressive. Figure 1 highlights the impact of this approach. On the left, the line chart tracks performance improvement on the Gaia benchmark as the number of feedback rounds increases. The top light blue line, representing Claude 3.7 Sonnet, climbs to an 8% gain around the 4th round. To the right, the bar chart compares the fine-tuned DeepVerifier 8B model against open-source baselines. It consistently achieves higher accuracy, averaging 32% compared to roughly 28% for the other models. Well, Figure 2 breaks down exactly how this verification pipeline operates. The left side illustrates the overall cycle, where an agent's initial answer is passed to the verification module, which either accepts it or sends back corrective feedback for a retry. The detailed breakdown on the right shows the internal logic. Instead of just guessing, the system identifies specific suspicious behaviors, like failing to access a primary source, and maps them to a failure taxonomy. It then generates targeted follow-up questions to check those specific errors, which allows a separate verification agent to confirm facts much more reliably. So, to build the failure taxonomy that drives this whole system, the researchers needed a solid dataset of agent behaviors. Table 1 summarizes the trajectories they collected for this purpose. It covers 90 unique tasks with nearly 3,000 total steps, ranging from simple two-step solutions to complex ones taking over 150 steps. Importantly, the ratio of correct to incorrect answers is almost perfectly balanced at 0.96, which ensures they have a rich, unbiased set of failures to analyze. Alright, Figure 3 visualizes the resulting taxonomy, mapping those 555 failures into 5 major classes on the left and 13 specific subclasses on the right. The wide blue band at the top indicates that finding sources is the most frequent failure mode, usually involving selecting wrong items. Just below, the orange and green streams show that reasoning errors and problem understanding are the next biggest hurdles. Finally, the red and purple bands at the bottom account for action errors and reaching the maximum step limit. Okay, Table 2 serves as an ablation study, proving that every piece of that pipeline matters. The top row shows the full DeepVerifier, achieving a balanced 73 F1 score. In the second row, removing the verification step creates a system with perfect precision but terrible recall, just 14%. This means it rarely flags errors, missing almost everything except the most obvious crashes. Finally, the third row shows that without the decomposition module, recall drops to 47%, confirming that breaking questions down is essential for spotting subtle mistakes. Wrapping up, 2 takeaways stand out. First, inference time verification offers a scalable path to reliable agents without the massive cost of retraining. Second, by structuring feedback through a clear failure taxonomy, models can effectively self-correct reasoning errors that typically stump standard approaches. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.